thing, so I hope that it does help. So let me actually go back a little bit. We're gonna start on page 38. But why are we talking about the graphing method? It all goes back to yesterday, right? Solving quadratic equations. We had two methods, right? Two methods, quadratic formula or the graphing method, as you can see the typo. It's already fixed on the original, so if you retake the course next year, it'll be fixed. I don't want to do that. Anyway, so this is what we're going to focus on today, and you will see that you should get the exact same answer, right? The answers, like your roots, your x-intercepts, stay the same, regardless of which method you use. However, graphic method is more convenient when it's an ugly equation. Like, I mean, like to solve, to bring everything over would be somewhat difficult, but it can still be done. I will show you how that is done, okay? So you're still doing the same thing here. Same thing as before, we're finding the x-intercept, right? Finding the x-intercepts, if possible, I should say, because not always are there x-intercepts, right? Some parabolas just do not cross. If lines do not touch, there are no x-intercepts. There is no x-intercept. And so we'll have, I'll explore two options here with you. Option 1, let y equal to 0. So if you see a y in that equation, just let it be 0, okay? Just get rid of, we're basically getting rid of it. Rewrite the equation in general form, and by that I mean you're gonna have, right, ax squared plus bx plus c equals to 0, right? You will have a 0 on one side, because think about it this way. Remember how it was like y is equal to something, right? Our equations always started. We're letting it be 0 now. So it will ultimately, when you're trying to solve, you're going to make it equal to 0. Watch it, what it says there. Then enter left-hand side, I call it this from now on, into y1, the right-hand side into y2. Then we use second trace 5 to find any and all x-intercepts. And you might think, well, we've done this all this time. Yeah, you have been doing this all along. When you found the x-intercepts, you were actually solving a quadratic at the same time. Okay. Option 2, let y equal 0 if present, so nothing changes there. Enter left-hand side into y1, right-hand side into y2. No rewriting necessary. That is the key here. That's why I really like this one. Then use second trace 5 to find any and all x-intercepts. Watch this note here. Since we are finding x-intercepts, you must state your answer and you will see why I'm giving you a warning there in just a little bit. Okay, solve the following using a graphing method. Okay, so there's on the test, please do not use the quadratic formula if I tell you to use the graphing method. The nice thing is you'll have the choice which option you would like to choose. Okay, and to be quite honest, I don't have the key in front of me because when I made this handout, I just made them as hard as I can possibly make them. And here we go. So let's do this together. So what we're going to do is option 1. We're going to do it on this side, and then option 2, I'll do it on the right side. Okay. So if you look at it, there is no y. So forget about the let y equal. If you look at the option there, let y equal to 0, don't have to worry about it. The second says rewrite this. So no y, check, right? Rewrite. And this is where you have to do a significant amount of work. So if you look at the whole thing, the left side is pretty clean, like it's x squared, x, and 50. On the other side, there's a little bit of work that needs to be done, which is distributing the 2 and getting rid of the bracket. So I'm going to go 32x squared minus 15x plus 50. And please take your time. Do not rush from one step to the next. So I'm multiplying that out. And I get this. Let me zoom into that because I'm going to stay on that side as much as I can. And so now let's bring everything over to the left, okay? So 32x squared. Why don't I use a different color? It doesn't hurt, right? So the 12x squared, which was here, comes over there. Then I switch to the next term, which is my x, right? Minus 15x. And this 250x, which is on the right-hand side, when it comes over to this side, it changes to negative. Then you have the 50. You bring over this 150, which comes over subtracting. And once you've brought everything over to the other side, then you have everything equal to 0. And that's what you want. And it doesn't matter if you want to take everything over to the right side, it's fine. Your signs will all be different, but your ultimate answer will be the same as mine. 32x squared minus 12x squared, I can do that. That's 20x squared. Negative 15x and negative 250 is negative 265x. Yikes, right? 50 and negative 50 is negative 100. And that is equal to 0. So basically, you type this into y1, and we type whatever's on the right-hand side into y2. And it's okay to show your work the way I'm doing it here. You don't have to write, I will put the left-hand side into y1, the right-hand side into y2. And then we just go stat, calc, 5. And we will come up with our x-intercepts. So let's go ahead and enter it. Just so you know, you're entering it manually, so turn off plot 1 right away. Okay, clear. I'm going to clear everything. So we have 20x squared minus 265x minus 100. Can't see that because I zoomed in, so let me do that again. And then y2 is equal to 0. I'm sure you're like, Mr. Erickson, that's what we used to do to find the x-intercepts. Yes. So everything is connected. There's nothing really that shouldn't be jiving. It should all be the same. Let's graph this now. And I hope you won't see a thing. I'm hoping. Okay. Oh, I saw that tail there. So let me introduce you to, because technology should be there to help us, right? If this is when I introduce, let's try that together. Press zoom. And then if you go all the way down, there's something called zoom fit. And 90% of the time it solves your problem. It will actually find the parabola. So let's hit enter or just 0, whatever you want to. Hopefully that solves it for us. Let's see. Okay. So you definitely have quite a bit that you're seeing. And look at your window. Let's press window. Just press it once. Look at your Ymin and Ymax. It changed that automatically so you could see most of the curve. Okay, so if you look at your graph, let's go back to graph. You're seeing the right side of this arm. We want to see the other side as well. So let's go ahead and change. So you obviously have to know what you're doing here. So x min, I'm gonna go negative 1,000. Why not? Right? If you're going 1,000 on the positive, I'm gonna go negative. and then hit graph again. And there I'm seeing both sides. But what am I interested in mostly? The X intercepts. So let's try this. Second trace 5. First, figure out where your cursor is. I'm going to the left here, and it's right there. You see it? It's on the left side. If yours is on the right side, just maybe come all the way over to the left here. And if I hit enter, 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 it's going to find the first X intercept, which is on the left side here. So let's write that down. Negative 0.370. And you're like, but I can't see it, Mr. Erickson. Like, why can't I see it? Because your window is so huge. That's why. I didn't want to overwhelm you with the zoom features. But here it is again, zoom. I'm going to zoom in. The second option. I'm curious to see, like, where does it cross? And that's where you have to, right now, if you press zoom in, watch this. You see that little cross there? The crosshairs? That's where it's going to zoom into. So I'm going to travel to, like, it's going to be hidden right now, but I'm going to travel further down and hit enter. And it will zoom in there. I don't know if you should see something like this if you press zoom in. And if you're still not happy, it's still there. The crosshairs are still there. So you can actually go to where you think it's crossing and hit enter again. And keep repeating that process. I'm just not going to do it. Like, it's for me, as long as I know that this is the X intercept, the one I wanted, I'm fine. Okay? So I probably overwhelmed you a little bit. I apologize. Let's go back to zoom fit. So I'm like, no, I'm going to try that again. Zoom fit. Just press that again. Oh, and in this case, it actually is showing me the left side, right? So it happens to just show this. Let's go ahead and see if there's another one. Second trace 5. I am here right now. So I'm going to travel past and then go over to the other side and then do the second trace 5 again. How do I know I'm, see my X value, I'm in the left, on the left side, I'm going to go towards the right. Keep going. If I keep going, my Y value is not positive, which means I went down under the X axis and then back up. And then you hit enter, enter, enter. And that is my other X intercept. That's my other X intercept. So these are the two X intercepts for this particular quadratic equation. So it might involve some significant, this is one of the harder ones you're going to get, just so you know. Like, it doesn't get harder than this. So on the second side here, so break this off and then say option 2 here. And let me just write this out one more time. I'm basically just writing out the original here. This is the one I like the most because you don't have to do all of this work. We just take it as is. You type this into Y1 and you take the right side and you type that into Y2. And then we go stat calc 5. Let's go ahead and do that right now. Hit y equals, I clear whatever's in there. You go 32x squared minus 15x plus 50. Then you hit enter, and you go 2 times 6x squared plus 125x plus 75. Make sure the brackets are there, okay? So this is what you should have right there. You got it? Let's hit graph now. There's a big chance. Okay, see one of them. And see, it's like, what's happening there? Why are there two curves? Well, obviously we have y1 and y2, right? So it could be two parabolas. It could be a parabola and a straight line. It depends on what I give you. But if you hit graph, it's the intersection of those two graphs that we're interested in. Okay, so we're gonna do this. Press zoom. Let's try zoom fit. I have a feeling that if you try zoom fit, it's going to help us out. You ready? Zoom fit. There's the one, and there's the other one. Not much has changed. Okay. I'm gonna ask you to hone in on this. So watch this. The y max is way up here. We're gonna bring it down to here. So whatever it is, we're gonna bring it down to less than half of it. So let's go to our window. And y max, we're gonna bring it down to like 10,000. Just change that for now. And then hit graph. Oh, there it is. Another one, look at the screen, okay? This is my X min. There's too much blank space here. That's why I can't see a whole lot of the graph. So I'm gonna bring it down to about half of what X min currently is. So window, I'm gonna bring it down to like -50. And then hit graph again. Do you see it now? Do you see it how they meet here and there? Okay. Let me just in your notes do this. Try zoom fit, right? Oh, too many O's there. Zoom fit, right? And then change window as needed. So you're basically gonna have to triage the situation. Like where's the intersection of those two curves? Because that's what I'm really interested in. So now let's go stat, calculate. No, sorry. Second. I just noticed that I was misleading you. Can you change the stat calc? I was completely off. I meant to say second trace intersect, right? That's what I meant to say here. Second trace 5, right? And we'll do the same thing here with the previous example. Sorry, guys. Second trace 5. You're basically finding the intersect. Stat calc, that's doing a regression, right? So second trace intersect. So let's try this again, right? So second trace intersect, And let's find the first one. We're closer to the bottom one there, so just kind of get close to it and then hit enter, 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 and you get negative 0.37. Watch this. Write this down. 59.82. What's going on there? Why are we getting that? Well, it's the coordinate of that intersection right there. And let's find the other one. Second trace 5. I'm going to go further up the curve where they meet again, right up here. Just get close enough. Enter, enter, enter. And that's 13.62. Okay. I'm running out of room there, so I'm going to go 13.62, 5,779.43. Very important. This part is very important. Notice that, right? These are the same, right? And so the x values are the same, but you have the y values here. If you're using this method, you only report it like this. You get rid of this, and you need to change that with 0. Okay, that is the key. If you're using that second method, you're going to have to only report the x values. So this would be 13.62, 0. Okay, so we get rid of the y values. You only report the zeros there. Only report x values. Only report x values. Okay. Let's wrap up here. Question. Could you do this one using the quadratic formula? This one right here. The answer is yes. Should you be getting the same answers? Yes. It doesn't matter which method you use, you should all be getting the same answers. So, for homework, there is no textbook, like they're all way too easy in the textbook, so I've made some. So if you go to the back side, I'm going to just ask you to do pages 39 to 41. So just keep going. And to be honest, I don't have the keys yet, so I would have to do them myself. So I will do that for you. But it's not in the workbook, okay? It's just in this booklet right here. The number one reason you would want to try, maybe if you can't do them all, I understand that. But it's your window. The window is going to be the biggest problem here if I ask you to use the graphing method. So make sure you know how to do that. Play around with it.